This lesson will cover the requirements for noise abatement procedures and the means by which these requirements are achieved. The current generation of turbofan engines are considerably quieter in operation than their predecessors, thanks to technological improvements. Nevertheless, the disturbance caused by aircraft noise is still a sensitive subject, particularly to those who live or work close to busy airfields, and especially in the areas beneath the departure and arrival routes. In an effort to reduce the effects of aircraft noise, EU OPS regulations require that procedures are established by operators for IFR operations in accordance with the ICAO PANS OPS document 8168. Each state has to detail noise abatement procedures for each airfield in the Aeronautical Information Publication, or AIP, the procedures being principally designed for turbojet aircraft, although propeller-driven aircraft, both piston and turboprop, are sometimes specified in the procedures. On a point of terminology, it is worth mentioning that the expression noise amelioration, from the Latin for better, is increasingly being used. However, since the UK AIP still uses abatement at the time of writing, we will go along with that. The procedures will consist of any or all of the following elements. First, the use of noise preferential runways. Secondly, the use of noise preferential routes. And thirdly, the use of noise abatement takeoff and climb or approach procedures. In addition to these airfield-related procedures, each aircraft type will have its own procedure, devised by the operators and manufacturer and agreed by the state authority. These will include performance-related power reduction and flap retraction heights and speeds, maximum body angles, or climb attitudes. Noise preferential runway procedures involve the use of specified takeoff or landing directions which are nominated to avoid noise-sensitive areas. Runways will not normally be chosen for landing unless they have suitable glide path guidance, usually an ILS, for use in poor weather, and precision approach path indicators, or PAPIs, in visual conditions. There are certain conditions under which a noise preferential runway will not be selected, namely, if the runway surface is contaminated by snow, slush ice or water, if the crosswind or tailwind components, including gusts, exceed 15 or 5 knots respectively, when wind shear is reported or forecast, or thunderstorms are expected to affect the area, or when the visibility is less than 1900 meters, or the cloud base for landing is lower than 500 feet. Noise preferential routes are established to ensure that departing and arriving aircraft avoid flying over noise-sensitive areas near airfields as much as possible. There are strict parameters which apply to the use of turns in noise preferential routes, principally to avoid manoeuvres which could be hazardous close to the ground. Therefore, noise preferential routes will not include a turn below an aircraft height of 500 feet or 150 meters above ground or obstacles throughout the turn. Aircraft would not have to exceed 15 degrees of bank, unless there is provision in the procedure for acceleration, which would allow for an increase in bank angle. Turns would not be required to be made at the same time as a noise abatement power reduction. There must be adequate navigational guidance to allow pilots to follow the route as published. This guidance would normally be from VOR DME radio beacons in the form of bearings and distances, but could include radar monitoring. The noise abatement regulations for turns after takeoff and obstacle clearance, laid down in PANS OPS Volume 2, permit turns at 400 feet or 120 meters, with terrain clearance of at least 300 feet or 90 meters. The safety criteria of standard departure and standard arrival routes concerning climb gradients and obstacle clearance will be taken into consideration when the preferential routes are established, and aircraft will not be diverted from their assigned route unless, Either it is at an altitude above the upper noise abatement limit, or a deviation is essential for safety reasons. In designing the routes, aerodrome operators have to specify the noise abatement objectives, but it is the aviation authority of the state in which the airfield is located who are responsible for ensuring that they do so. Likewise, the state of an aircraft operator is responsible for the approval of any associated safe flight procedures developed by the operator. Where noise abatement procedures exist, they will only be used if there is some benefit to be expected. Notwithstanding this limitation, a pilot in command has the authority to decide not to carry out a procedure if he feels it would not be safe to do so. Also, procedures involving reduced power takeoffs should not be used in the adverse weather conditions previously described in the section on noise preferential runways, namely runway contamination, crosswind, tailwind, wind shear, thunderstorms, and poor visibility or low cloud base. Noise abatement climb procedures are planned according to a number of parameters. The first and basic one is that no procedure should start below 800 feet, or 240 meters above the airfield. Where an operator specifies a particular procedure for an aircraft, it will apply to all aerodromes. There can be no more than 2 climb procedures for any aircraft type. That is, one normal and one for noise abatement. A rider to any procedure is that, in the event of engine failure, power settings can be whatever is required by the pilot, and noise abatement considerations no longer apply. For noise abatement, the minimum thrust for the climb, with flaps and slats deployed, will be the lesser of maximum climb power and that required to maintain the engine outnet climb gradient. The thrust levels for various conditions and configuration would be found in the operations manual, and take account of the use, when appropriate, of engine anti-icing, which reduces engine power. All procedures must comply with the normal minimum climb gradient based on the obstacle data, all of which will be available to the operator, but the procedure should not demand a body angle or pitch attitude that exceeds the aircraft's acceptable maximum. Having looked at these parameters, you will be shown in the next scene how they are applied to 2 typical climb profiles. The diagram shown on the screen shows a typical noise abatement profile in which the aim is to alleviate noise close to the aerodrome. After takeoff, the aircraft accelerates to V2, plus a safety margin of 10 to 20 knots, and climbs to 800 feet above the airfield. V2 is takeoff safety speed, the speed above which the aircraft is controllable in the event of an engine failure. The extra speed keeps the body angle below maximum, while still enabling a good rate and angle of climb. At or above 800 feet, power will be reduced to the noise abatement setting, but flaps and slats will be left in the takeoff position to maintain the extra lift, with speed maintained at V2 plus 10 to 20 knots. Above 3,000 feet, the aircraft continues the climb and accelerates to en route climb speed, retracting flaps and slats at the appropriate speeds. The second profile shows a climb intended to alleviate noise distant from the aerodrome. The first segment to 800 feet is identical to that of the first profile. In the second segment, either the aircraft climbs, accelerating towards VZF, minimum speed with 0 flap, and reducing power as flaps are retracted, or alternatively retracts the flaps and then continues the climb, reducing power and climbing at VZF plus 10 to 20 knots. Above 3,000 feet, the aircraft would then accelerate to its en route climb speed. For noise abatement approach procedures, 2 basic parameters are applied, namely that the aircraft will be in the landing configuration from the earlier of 5 nautical miles from the runway threshold or the ILS outer marker, and that no excessive rates of descent will be required. There are several safety considerations to be taken into account regarding glide path angle, which should not be above the ILS or Precision Approach Radar or PAR glide path, above the PAPI visual glide path, or above 3 degrees, unless the ILS glide path is higher. Note that the PAR talkdown mentioned in these restrictions is available in the UK only at certain military airfields. Noise abatement restrictions should not require a turn onto final approach at a distance less than that which, on a visual approach, would allow an adequately stabilised descent to the threshold. For an instrument approach, the aircraft should be established on the final approach track before intercepting the glide path. A procedure that has been quite widely adopted is the stabilised approach, which is shown on the screen. A continuous descent is flown from the initial approach fix, and gear and flaps are left up till late in the procedure, just before reaching the 5-mile point. This type of technique not only reduces the noise footprint of the aircraft, as it requires a more constant and lower power at higher altitudes until intercepting the final 5 miles or so of the approach, but also has the benefit of saving a fair amount of fuel over a period of time. For landing, noise abatement procedures do not prevent the use of reverse thrust and reverse pitch, although individual local procedures may request the minimum use of reverse. Also, displaced landing thresholds should only be used for noise abatement if aircraft performance requirements can be met on the reduced runway length. Noise abatement procedures are designed to minimize the impact of aircraft noise on areas surrounding airfields, but safety is always of paramount importance. Although the procedure parameters are laid down with this in mind, a pilot in command always has the authority to discontinue a noise abatement procedure, to follow an alternate normal one, or use whatever power settings he deems fit, if he feels that safety considerations so dictate.